Hello, my beloved students. I am happy to meet you today. Today, inshallah, we are going to study a new lesson in geometry. We call it angle, bisector, and proportional parts. So concentrate with me. If we have an angle like that, we will draw a triangle here. Yes, we have a triangle. ABC triangle. Okay, A, B, C. This is a triangle, and if we choose an angle as A and we bisect it like that by the bisector AD, we have here measure angle CAD equals measure angle BAD. Okay, we call this AD is interior bisector or internally bisector because it bisects the angle from inside. Okay, if we have a triangle here and the AD bisector, then we will have a rational proportional like that. Look carefully. AC over AB, AC over AB will be equal what? We will be equal the ratio CD over DB. CD over DB. So if we have a triangle, we have any angle here like that, and we have a bisector from inside of the angle, then concentrate well and pay attention. We have here the ratio AC over AB equals CD over DB. We will start from A because it's the same angle that we bisect it. So from the right side, AC over AB, and go again to C to say CD over DB. Okay, if we have another angle, yes, we discussed about the interior bisector. But if we have a triangle and we have external angle or exterior angle of triangle, so look with me, we have here a triangle. We will call it also A, B, C, and we have here exterior angle. We call it CAE like that. And if we expand the ray BC like that, and we have exterior bisector of the angle, okay, it is an exterior bisector like that. We have here the point D. Okay, we have a triangle ABC, and we have also AD is a bisector of the exterior angle CAE. So we have the measure angle EAD equals the measure angle CAD. Look carefully here and pay attention to find out what is the ratio. We have proportional ratios here, like the last one. Okay, we have AB over AC. We write AB here over AC will be equal, pay attention to me, BD, which is the bisector intersection point with the ray BC here. So we have AB over AC like that, equals BD over, we return again to DC. So we go BD to D, and we return again to C. Again, AB over AC equals BD over DC. We write BD over DC. We have proportional parts here. The meaning of proportional, that ratio equal another ratio, and we can say equal many ratios. So we say that these ratios are proportional if these parts are proportional. AB is proportional with AC, BD and DC if the ratio here equals the ratio here. So we have now two proportionals. Okay. Yes, my dear students, so we have two triangles. The triangle have a bisector or has a bisector from inside, we call it interior bisector, and if it has a bisector from exterior, we call it exterior bisector, and we write the proportional to it. Look carefully here to solve an example here. If we have a triangle like that, ABC is a triangle like that. We have A, B, C, and we have the bisector here, AD. AD is the bisector of interior angle A, and we have also the length of AB equals 4 centimeter, and the length of AC equals 6 centimeters, and we have the length of BC 5 centimeters like that. BC, the length of all of BC equal 5 centimeter, and the question is find the length of each of the line segment BD and the line segment DC. Look carefully here. We have a triangle and we have a bisector. We have remind that if we have interior bisector, then the ratio will be AB, yes, say with me, over AC. AB over AC equals what? BD, yes, excellent students, which say BD over DC. BD over DC. AB equals 4 centimeter, so put 4 here. AC equals 6 centimeter, so we put 6 here, equals BD. We have no length for BD now, so we want it, over DC. It's unknown also, so let BD equals X. So DC equals what? DC equals 5 minus X. We have the total length of CB equals 5 centimeters. So if we put DB equal X, then DC equal 5 minus X. BD equals X now, and DC equals 5 minus X. By using cross multiplication here, 6 multiplied by X will be 6X equals, we multiply 4 by the bracket 5 minus X. 5 times 4 equals 20, minus 4 times X equals 4X. like that. Okay, so we have here 6x equal 20 minus 4x. We can transfer negative 4x here and write it like that. 6x plus 4x equal 20. 6x plus 4x equals 10x equal 20, and x here equals 20 divided 10 equals 2 centimeters. If we have x here equal 2 centimeters, then dB of course will be 2 centimeter, and dC equals 5 centimeter minus 2 equals 3 centimeter. And this is the solution of the first example here. Okay, my dear students, look carefully to the sides. If we have a side like BC, the whole side equal any number, then suppose that the smallest part or any part of them, x, and the other will be the number or the length minus x. Concentrate with me to find to solve another example here. We have an angle here. We will draw a triangle like that. This is a triangle A, B, C, and we have exterior bisector which AE. E here belongs to the ray CB. Okay, this angle equals the measure of this angle. Okay, and we have some length here. AC equal 9 centimeters, CB equal 5 centimeters, and AB equal 6 centimeter. Okay, this is the ray. The solution, the required solution is to find the length of the line segment BE and the line segment CE. Solution: we have triangle here ABC, and we have an exterior bisector for the angle BA. We can call it F. Okay, and concentrate well to find out the ratio. We have here AC over what? Over AB. Pay attention well. We write AC over AB. It equals what? Equals CE here over CB. Okay, sorry, CE over EB. We return again from E. We concentrate about the point E. So we go to E here and return from it to B. So we say CE over EB. We have AC equals 9 centimeter and AB equals 6 centimeter. CE here equals 5 plus we have here CB equal 5 centimeter plus BE we don't know its length, so we can call it X. Okay, so CE equals 5 plus X over EB, it's X itself, and using the cross multiplication here, 9 times X will be 9X equal 6 times 5 equal 30, 6 times X equals 6X, and we will try to find out the solution of this equation. 9x minus 6x will be 3x here, equal 30. Okay, so x will be 30 divided by 3 equals 10 centimeter. And he would like to find out the length of BE. BE here is 10, and CE equals 5 plus 10. So its length equals 15 centimeter. But 10 here is BE, so BE equals 10 centimeter. So we have solved this example now. Okay. Look carefully, my dear students, and don't make common mistakes. If we have a bisector AE, we go to from BE and return it. Okay, we have an example here, so pay attention to me and look carefully. We have a triangle ABC. We have a triangle like that. A, B, C is a triangle, and we have AX like that, and we have two bisectors to the angle AXB like that. The first bisector, its interior bisector for it. So this angle equals this angle, and we call this point D. So XD is the bisector for the angle BXA. And we have another bisector. We call it XE, and it bisects the angle AXC. Okay? And we have here XEDE, and we would like to prove that DE DE is parallel to BC. This is the required to prove. We have a triangle, as you see, ABC, and we have AX as a line segment between A and X, and a bisector for this angle XD, and another bisector for this angle AXC. Okay, we will use the first triangle ABX and the bisector XD. We say that the ratio will be XB over XA, XB here over XA will be equal what? Yes, we will be equal BD over DA. BD over DA, and we call it the equation number 1. This is for triangle ABX. And we move to another triangle, the other triangle AXC. We will find that XE here is the bisector of the angle AXC, and we can say that XA over XC will be equal AE over EC, and we call the equation number 2. And pay attention to an important given for us. He gives us that XB here equals the length of XC. So we try to search about XB and XC here. We will find out that where XB xb here, we can replace it by xc. Okay, and we have here the ax is the same, so look carefully for this ratio. We have this ratio here, xc over xa equals bd over dA here. Okay, and we can make it upside down. It's possible for the ratio, so we will write it xa over xc equals dA. Yes, dA over bd. So we have two, the one, but one dash. Okay, look carefully for this. We have xa over xc and we have xa over xc, so it is the same ratio. So we can say that ae over ec equals dA equals bd. Okay, look carefully for this ratio in the triangle. We'll find AD over DB equals AE over AC. If we have AD over DB equal AE over AC, we can deduce easily that ED here is parallel to CB. Okay, my dear students, let us go to a little break and we'll return again.
الماضي ده تاريخك والحاضر ده ملكك والمستقبل ده حلمك. دراسات الاجتماعية السنة دي ليها شكل تاني.
Okay, my dear students, hello again. Let's go to another example here. If we have a triangle called ABC like that, draw with me if you want. We have ABC is a triangle. We have here A, B, C, and we have interior bisector like that. AD is an interior bisector, and this angle will be equals this angle, and we have DB equals 12 centimeter and CD equals 18 centimeter, and we have the perimeter of triangle ABC equals 80 centimeter as a given here, and they are required to prove or to find the length of the line segment AC and line segment AB. Okay, concentrate with me. We have here the perimeter of the whole triangle AB plus BC plus CA equals 80 centimeter, and we have also CB equals 18 and 12. If we have 18 and 12, their sum will be what? Will be 30. Okay, so this AC and AB equals the remainder, so 80 minus 30 equals 50 centimeter. 50 centimeter is the length of AB and AC. If we let AB equals x, okay, then AC will be 50 minus x. So we have AB equal x, AB equal 50 minus x, BD equal 12, DC equal 18. And we have AD is a bisector or interior bisector of the angle A. So we'll use it to draw or to find the ratio. We have AB here like that over AC. AB over AC will be equal BD over DC, and AB equal x, AC equal 50 minus x, and BD equals 12, and DC equals 18. And by using cross multiplication here, we will find out that 18 times x equals, or we can start with 12. 12 times 50 equals, we can simplify this. If we divide 12 by 6, it will be 2, and 18 divided by 6 equals 3, so it's simplest form. So we can use 2 over 3, it's simplest than 12 over 18. We multiply 2 by this number and 3 by this number, so 3 times x equals 3x here, equals 2 times 50 equals 100, minus 2 times x equal to x, and we transfer negative to x here to find to be positive. So 3x plus 2x equal 5x, 5x equal 100. Okay, we can divide this 100 by 5, so x will be 100 divided by 5, so x will be 20 centimeters here. X is the length of AB, so we can easily say that AB here equals 20 centimeter, and AC equals 50 minus x, which is 20, equal 30 centimeters. Okay, we have found out AC, the length of AC, and the length of AB. Okay, my dear students, concentrate with me to solve another example. Okay, let's go to draw it. We have a triangle here, ABC. This is a triangle. Okay, ABC triangle, and another one, another triangle, BCD, like that. B, C, this is D, sorry. ABD is a triangle, and this is BCD is another triangle here. Okay, and we have a bisector. Let us draw the other bisector by red color. We have here a bisector of the angle A, and we call this point E, and we have here EF, parallel to BC, and required to find out the length of DC. And we have AD equal 12 centimeters, EB equals 8 centimeters, and DF equals 6 centimeters. Okay, we have AB, AD, DF, but we haven't DC. DC is the whole side, and we have also only one part is DF. So let's use the theorem here. In triangle ABC, ABD, we have a bisector AE. So we can say that AB over AD equals BE over ED. Let us call it 1. And from the other triangle here, we have EF is parallel to BC. So we know from the last lesson that DE over EB, or we can start from B, BE over ED equals what? Equals CF over FD. And we call it number 2. This is from triangle number 1, or triangle ABD, and this one from triangle BCD. Okay, let's substitute here. We have AB equals 8 from this one, AB equals 8, and AD equals 12. Let's simplify it first. 8 divided 4 equals 2, and 12 divided 4 also equals 3, and equal BE over ED. And from the other triangle, we have BE over AD. It is the same ratio from the first triangle and second triangle. So we can say that this ratio, which is 2 over 3 now, equals CF over FD. We have FD equal 6 centimeter, and CF, we don't know its length. So concentrate with this ratio and this ratio to find the length of CF. The length of CF equals 6 times 2 over 3, as you learned before from the properties of proportional. So 6 divided 3 equals 2, 2 multiplied 2 equals 4 centimeters. So CF now equals 4 centimeter, and we can easily find the length of DC, which is equal DF plus FC here. DC equal DF plus FC, so it's equal 6 plus 4, so it's equal 10 centimeter. Okay, let's move to another question. Yes, we have many examples to solve here. Yes, concentrate with me. We will draw another triangle here. Like this. This is a triangle. We call it A, B, C triangle, and we can expand BA here. Okay, and we have interior and exterior bisectors here. We have AD as a bisector of the triangle, but it is interior bisector, and we have exterior bisector AE, like that. This is E. Okay, and we bisect this angle. We can call this point as F, and we have the length of AB equals 8 centimeter, AC equals 6 centimeter, and we would like to find out DB and CD and also CE. We can call CE is Y, and we have CB equals 7 centimeter. This is the length of CB. The whole length of CB equals 7 centimeter. So we can call DB equal X and CD equals 7 minus x. So we have dB equal x centimeter, DC equals 7 minus x centimeter because the whole length of CB equals 7, and we have AC equals 6 centimeter and AB equal 8 centimeter, and the request is find the length of the line segment DE. DE contains DC and CE. We have here DB equal x, DC equals 7 minus x, and CE we call it y. We will try to find out the ratio. We have AD bisector, so we can say AB over AC equals BD over DC. AB equals 8 centimeter and AC equals 6 centimeter. BD is x and DC equal 7 minus x. And let us simplify this ratio. 8 and 6 can be divided by 2. It will be 4 over 3. And using cross multiplication, here 3 times x equal 3x, like that. And 4 multiply 7 minus x. 4 multiply 7 equals 28. Minus 4 times x equal 4x. And you can transfer x here to be 3x plus 4x equals 28. So 7x equals 28. So x here will be 28 divided by 7. X equals 28 divided by 7 equals 4 centimeter. So dB here equals 4 centimeter. Remember that. We have 4 centimeter here for dB. And DC equals 7 minus x. So it's 7 minus 4 equals 3 centimeter. And we would like to find out CE, which is y. So we will use the external angle or the bisector, external bisector of the angle CAF. So contrasted with me, it's AB over AC equals BE over EC. Remember, BE, you go there to BE and return from E here to Y, to C. So BE over EC. And let us substitute AB here equal 8 and AC equal 6, and it is 4 over 3 in simplest form. Okay, BE equals what? Here BC equals 7, and we can say that CE equal Y, so it's 7 plus Y. It's easier. Over EC, it is Y. And now we will try to find out the Y. We have here 4Y equals 3 times 7 equals 21 plus 3 times Y equals 3Y. So we have here 4Y minus 3Y equals Y equals 21 centimeter. Here Y equals 21 centimeter. By adding CD, which is 3 centimeter, plus 21, so DE will be equals 21 plus 3 equal 24 centimeter. It's a long example, so it's no problem about it. Okay, let's go to another thing. Sometimes we get a triangle and interior bisector and the exterior bisector, and ask us what is the angle between these two bisectors. To find out this, concentrate with me. If we have a triangle like that, we have a triangle, we call it ABC, and we can call this point F, and we have interior bisector for this angle A, we call it AD, so this angle equals this angle, and we have external bisector for the angle A, we can call it D. And someone ask you that, prove that the angle DAE, prove that the measured angle DAE equal 90 degrees. Look carefully to this. We have the angle DAC, measure angle DAC equals half what? Half measure angle BAC. This is number one. And we have this angle, which is CAD, measure angle CAD equals half the measure angle CAF. This is the equation number 2. And by adding, we will find out by adding this angle with this angle, and find out that measure angle DAC here plus measure angle CAD, by adding the left side with each other, equals the right side, half measure angle BAC plus half measure angle CAF. What is half? What is this? This is a straight angle. We call it, or its measure, we know that its measure equal 180 degrees. So we can say that half 180 equal 90 degrees. So the angle DAE, which is the sum of these two angles, measure angle DAE, okay, DAE, sorry about that, okay, we have this angle plus this angle, half the whole angle, which is 180, so it's 90 now. So we can say that DAE equals 90 degrees. So we deduce that the two bisectors AD and AE, we have internally bisector and external bisector here for the same angle. They are perpendicular. Perpendicular means that the angle between them equals 90 degrees. Okay, so keep well this information, that the interior bisector of an angle of triangle and the exterior bisector of the same triangle are perpendicular. That means the angle between them equals 90 degrees. So look carefully and find out the following example. If we have here a triangle like that, ABC, and we have a bisector AD like that, AD here is the bisector. Look carefully. Okay, AD here equals what? Equals square root AB multiplied by AC, AB, AC minus what? BD times DC. Okay. 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 My dear students, wait us, inshallah, the next Friday to discuss about another lesson. Goodbye and good luck.